Game Theory Class 8 Video 2. In this video we're going to do another example of the IESDS algorithm, the Iterative Elimination of Strictly Dominated Strategies algorithm. If you recall, this is an algorithm which helps you reduce the size of a game by eliminating iteratively strategies which are irrational. Right? You eliminate the strictly dominated strategies. And this is something that makes sense, because if you recall, we said that a rational player would never play a strictly dominated strategy. So if the game has a strictly dominated strategy, we might as well just cross it out and forget about it. But then we end up with a new game. After we've crossed out the strictly dominated strategy, we end up with a new game, and we can reapply the same logic again and again and again, iteratively, until we've rounded down the game as much as possible. That's the idea, and let's do another example right now. So here's a game, and the question is just apply the IESDS algorithm. So the first thing you need to do is you need to find a strictly dominated strategy. Okay, so maybe I will compare like x and y. I'll compare x and y. So 4 is bigger than 3, but 2 is less than 4. Okay, not good. Maybe I'll compare y and z. 3 is bigger than 1, 4 is strictly bigger than 3, 3 is strictly bigger than 2. That is good, because that means that y strictly dominates z. So z is a strictly dominated strategy. Okay, so we eliminate it. And I'll cross it out like this. And now I'm going to redraw the table. I will say a note on how to answer these questions on exams and in homeworks. You're expected to write out all of this. In particular, you're expected to write out what dominates what. Okay? And then I want to see you actually cross out the column, and I definitely want to see you rewrite the whole table without the strategy which you've just eliminated. So you can't cross out multiple things on the same table. You need to redraw the table after every elimination. 1, 2. Okay, so here's the new table. And now I'm going to look for a new strictly dominated strategy. So maybe I'll compare A and B. 1 is less than 2, and but 5 is bigger than 1, so not good. They're not a good pair. Maybe I'll compare B and C. So 2 is less than 4, and 1 is less than 5. That's better. So now we have that C dominates B strictly. So B is a strictly dominated strategy. So we eliminate B. Okay, now I'm going to redraw the table. I just have A and C on the left now. So it's 1, 4, 5, 3, 4, 0, 5, 3. Okay, so let's look to see if there are any more strictly dominated strategies. Maybe I'll compare X and Y. So 4 is strictly bigger than 3, but 0 is strictly less than 3. So nothing good there. Maybe I'll compare A and C. 1 is strictly less than 4, but 5 is less than or equal to 5. Okay, there's not a strict thing there. So we do have that C weakly dominates A, but not that C strictly dominates A. So there are no more strictly dominated strategies. What does this mean in terms of the game? This means, so we stop. That's the end of the algorithm. We can't go any further. To apply the algorithm, you need a strictly dominated strategy, and there simply aren't any more left. Okay, so this is as far as the algorithm goes. And in this case, we can't say what the rational outcome of the game is because we haven't rounded it down to one possible outcome. We got stuck at this 2 by 2. But it's better than nothing. I mean, if you think we started with a 3 by 3, so that was 9 possible outcomes, and we've rounded it down to 4 possible outcomes. So we've greatly simplified the game, and that's a useful thing to do. That's the end of this example and the end of this video.